Welcome to our exploration of ecosystem services, a concept that means different things to different people. This diversity of interpretation is both a strength and a challenge. On one hand, it sparks new conversations about the importance of biodiversity in the environment, engaging a wide range of perspectives. On the other, it complicates efforts to measure, monitor, and manage these services, especially when definitions vary. In this video, we'll guide you through the terminology, frameworks, and debates that shape our understanding of ecosystem services. Our journey will help clarify how nature supports human well-being and why consistent definitions matter for effective policy and management. Term ecosystem services acts as a boundary object, an idea that adapts to various viewpoints while maintaining a core meaning. This flexibility allows scientists, policymakers, and the public to engage in meaningful dialogue about the value of nature. However, as we move from discussion to action, especially in measuring or managing these services, the lack of a shared definition can create confusion. If we can't agree on what ecosystem services are, it becomes difficult to trust the evidence or make informed decisions. This scene sets the stage for understanding why clarity in definition is crucial for both scientific analysis and practical application. Different organizations and assessments define ecosystem services in unique ways. The Millennium Ecosystem Assessment describes them as the benefits ecosystems provide to people. Meanwhile, TEB emphasizes both direct and indirect contributions to human well-being. Some frameworks treat services and goods as synonymous, while others, like the UK National Ecosystem Assessment, distinguish between goods, benefits, and services. Despite these differences, the common thread is the recognition of nature's importance to people. The challenge lies in characterizing the ecological structures and processes that underpin these benefits in ways that can be analyzed and managed. Clarify the relationships between ecosystems and human well-being. Researchers developed the cascade model. This model illustrates a pathway from ecological structures and processes, through functions and services, to the benefits and values people derive. The cascade helps distinguish between each step, making it easier to analyze and communicate how nature supports society. It serves as both a communication tool and an analytical framework, guiding discussions among experts and laypeople alike. By mapping out these connections, the cascade model strengthens our ability to solve real-world problems related to ecosystem services. Cascade model highlights 5 key sets of ideas: ecological structures and processes, functions, services, benefits, and values. Ecological structures include habitats like woodlands or processes such as the nitrogen cycle. Functions are the characteristics or behaviors of ecosystems that make them useful to people, such as a woodland's ability to slow water runoff. Services are the final outputs from ecosystems that directly contribute to products or conditions valued by people. Benefits are the changes in well-being, like improved health or safety, while values represent the importance people assign to these benefits, whether monetary or otherwise. Term function in ecology can be complex. Some experts use it interchangeably with process, while others see it as the capacity of ecosystems to provide services. For example, a woodland's ability to mediate runoff depends on its canopy characteristics, which can be managed to enhance certain benefits. Identifying these functional characteristics is essential for understanding how ecosystems and people are linked. By distinguishing functions from services and benefits, we can better manage and optimize the properties that make ecosystems valuable to society. In the cascade model, services are the final outputs from ecosystems, still connected to their underlying structures and processes. Goods and benefits are the things that have value to people, such as harvested timber or improved health. The distinction is important. Services are what ecosystems provide, while goods and benefits are what people receive and value. This separation helps clarify how different ecosystem properties contribute to human well-being and supports more precise measurement and management strategies. Single ecosystem can provide a range of goods and benefits. For example, a stand of trees may slow water runoff, offer shelter from wind and dust, and provide recreational opportunities. Each benefit depends on different functional characteristics, such as branch structure, stem density, or stand age. Recognizing this diversity is crucial for understanding the full value of ecosystems and for designing management practices that maximize multiple benefits. Benefits from ecosystems are important because they change people's well-being, improving health, security, social relations, or personal choices. The value people assign to these benefits can be expressed in many ways, including monetary terms, moral judgments, aesthetic appreciation, or spiritual significance. These values influence how societies choose to manage and protect ecosystems, shaping policies and actions that affect both nature and people. Cascade model includes feedback loops, showing how the values people assign to ecosystem benefits can influence management decisions and ultimately the ecosystems themselves. For example, if society values woodland protection, policies may be enacted to preserve or expand forests. This feedback highlights the dynamic relationship between people and nature, where human actions can modify the very systems that provide essential services. While the cascade model is a useful tool, it simplifies the complex relationship between ecological structures, processes, benefits, and values. In reality, ecosystems are interconnected networks, with multiple structures and functions supporting a suite of benefits. The model provides a vocabulary and framework for understanding these relationships, but cannot capture every nuance. Recognizing its limitations helps us use the cascade as a starting point for deeper analysis and discussion. Cascade model serves as an entry point for connecting biophysical and social systems. It helps structure thinking about the links between nature and people, guiding discussions about what counts as a function, service, or benefit. The model's flexibility allows it to be adapted to different contexts, making it a valuable tool for researchers, policymakers, and practitioners working to solve real-world environmental challenges. Cascade model has inspired studies on the supply and demand of ecosystem services. Researchers have used it to analyze how green infrastructure in cities meets people's needs, how supply and demand change over time in landscapes, and how different stakeholder groups influence service provision. These studies reveal that supply is shaped not only by ecological factors, but also by human needs, management practices, and scale sensitivity. Researchers have applied the Cascade model to map and assess ecosystem services in various settings, from riverscapes to wetlands. By identifying the components of plant diversity most correlated with ecosystem properties or analyzing pollination from a policy perspective, these studies demonstrate the model's versatility. The Cascade helps clarify the links between ecological characteristics and the services people value, supporting better management and planning. Scientific and policy communities are keen to develop indicators that can mainstream the concept of ecosystem services. The Cascade model has been used to propose new indicators for coastal protection, develop spatial indicators for potential and supply, and support policy frameworks. These efforts aim to identify synergies and trade-off between ecosystem service supply, biodiversity, and conservation, making the concept more actionable for decision-makers. Cascade model has also been integrated into broader modeling approaches, such as Bayesian belief networks, to operationalize ecosystem services-based management. These models help decision-makers identify program needs, activities, outcomes, and values, supporting adaptive management in diverse contexts from riparian buffer strips to agricultural landscapes. Beyond empirical applications, the Cascade model has inspired theoretical work to better understand mapping tools, research gaps, and the integration of stakeholder knowledge. For example, researchers have used the model to categorize ecosystem service research, analyze the evolution of supply and demand, and explore the impact of policies on agricultural landscapes. These studies highlight the need for analyses at relevant scales and the inclusion of diverse perspectives. Researchers have adapted the Cascade model to better represent cultural ecosystem services, which often arise from people's perceptions of nature rather than nature itself. For example, modifications have been made to distinguish cultural services from other types, emphasizing the importance of experiences, inspiration, and spiritual values. This highlights the need for frameworks that can capture both material and non-material benefits from ecosystem. Their adaptations of the Cascade model include the idea of a reverse application, which looks at the full cycle of ecosystem service generation and management. This approach is particularly useful in planning, where uncertainties, legal frameworks, and conflicting interests must be considered. By broadening the model, researchers can better address the complexities of real-world decision-making. Ultimately, the Cascade model is best seen as a heuristic, a tool for starting conversations and focusing thinking about ecosystem services. While it may not capture every detail, its simplicity makes it accessible and adaptable. For specific applications, more detailed frameworks may be needed, but the Cascade remains a valuable starting point for linking people and nature. Classifying ecosystem services is challenging due to the fluid nature of the concept. Different initiatives use varying definitions and categories, making it difficult to compare results or design standardized systems. For example, the classification of water services in forests can be ambiguous, and naming conventions often differ between frameworks. These challenges highlight the need for systems that can translate between different typologies. To address classification challenges, the Common International Classification of Ecosystem Services (CICES) was developed. Led by the United Nations Statistical Division, CICES provides a standardized way to identify and report final ecosystem services. It is widely used in Europe and beyond, supporting efforts to map, model, and compare ecosystem services across regions. The framework is designed to be hierarchical and adaptable to different spatial and thematic scales. The ICS organizes ecosystem services into a hierarchy: sections, divisions, groups, and classes. At the highest level are three main categories: provisioning, regulating, and maintenance, and cultural services. Each level becomes more specific, allowing users to report at the appropriate level of detail for their application. This structure supports both detailed local studies and broader regional comparisons, making CICS a flexible tool for ecosystem assessment. Visioning services include all nutritional, material, and energetic outputs from living systems. This category covers food, water, raw materials, genetic resources, and energy sources like fuel wood. CICS distinguishes between outputs from biological materials and water, and further divides energy sources into biomass-based and animal-provided power. These distinctions help clarify what counts as a provisioning service and support consistent reporting. Regulating and maintenance services are the ways living organisms mediate or moderate the environment, affecting human performance. This includes waste degradation, air and water quality regulation, climate regulation, erosion control, and pest management. By classifying these services, CICES helps highlight the many ways ecosystems support human health, safety, and productivity. Cultural services are the non-material outputs of ecosystems that affect people's physical and mental states. These include recreation, inspiration, spiritual and religious values, education, and aesthetic experiences. CICS recognizes both natural and semi-natural settings, emphasizing the importance of living processes in shaping cultural benefits. By including these services, the framework acknowledges the full range of ways nature enriches human life. Key debate in ecosystem service classification is whether to include abiotic outputs like wind or hydropower. Some argue that including non-living outputs dilutes the focus on biodiversity, while others note that the public may not distinguish between biotic and abiotic contributions. CICS ultimately excluded abiotic outputs from its main classification, but provided a parallel table for reference, highlighting the ongoing need for a comprehensive vocabulary. Like some frameworks, CICS does not include supporting services such as nutrient cycling or primary production. Instead, it focuses on final output that can be valued and assessed. Supporting services are seen as underlying processes that enable final services, and discussions about their management are considered a separate conversation. This approach helps avoid double counting and keeps the focus on measurable outcome. Identifying what counts as a final service can be tricky. For example, is it the water from a lake or the fish that live in it? The answer depends on the context and the purpose of the assessment. CICES allows flexibility, but users must make careful judgments to avoid double counting and ensure clarity. This scene illustrates the importance of context in ecosystem service classification. Persistent challenge in classification is distinguishing between services and benefits. Some frameworks treat them as the same, while others define services as ecosystem activities and benefits as enhancements to human well-being. CICES uses the concept of a production boundary to separate the two, making it easier to identify what can be valued and measured. This distinction is especially important for cultural services, where the line between service and benefit can be blurred. Cultural services present unique classification challenges. They are often linked to environmental settings or practices, such as recreation, education, or spiritual fulfillment. CICES addresses this by framing cultural services at higher levels as settings and at lower levels as specific activities. This approach helps capture the diverse ways people interact with and benefit from nature, even when the outputs are non-material. Experts agree that multiple ways of classifying ecosystem services are needed, depending on spatial scale and other characteristics. The stabilization of CICES as version 4.3 was intended to encourage practical testing and refinement. As ecosystem accounting is still experimental, ongoing feedback and adaptation are essential to ensure classification systems remain relevant and useful. CICES has been used in national ecosystem assessments, such as those in Germany, Belgium, and Finland. It supports accounting, indicator development, and historical analysis of ecosystem service output. While the framework is suitable for many uses, it may need adaptation for specific contexts, such as marine or coastal ecosystems, or for integrating with other typologies of ecosystem function. Recent developments, such as the FEGS system by the US EPA, aim to better align services, benefits, and beneficiaries in classification systems. This approach seeks to provide a more complete picture of the service cascade, ensuring that all relevant aspects of ecosystem service provision are captured and understood. The concept of ecosystem services is simple in theory but complex in practice. To realize the benefits of managing natural capital for human well-being, we need consistent ways to describe and measure ecosystem services. Ongoing discussion and refinement of frameworks like the Cascade Model and CICES are essential for operationalizing the ecosystem service paradigm and supporting effective policy and management. Development of ecosystem service frameworks and classifications is a collaborative effort, supported by international projects and agencies. These partnerships bring together diverse expertise and perspectives, ensuring that the resulting tools are robust, adaptable, and widely applicable. Continued collaboration will be key to advancing the science and practice of ecosystem services. As ecosystem service frameworks are tested and refined, research and evidence play a crucial role. Practical applications, case studies, and feedback from users help identify strengths and weaknesses, guiding future improvements. This iterative process ensures that classification systems remain relevant and effective in a changing world. Looking ahead, there is a need for richer vocabularies and more nuanced classification systems that can capture the full range of ways people and nature are linked. This includes considering spatial scale, excludability, rivalness, and other characteristics. Ongoing innovation and adaptation will help ensure that ecosystem service frameworks meet the needs of diverse users and contexts. Integrating ecosystem services into policy and management requires clear definitions, robust classification systems, and effective communication. By bridging the gap between science and decision-making, frameworks like the Cascade Model and CICES can help ensure that natural capital is managed sustainably for the benefit of current and future generations. Consistency in defining and measuring ecosystem services is not just an academic concern, it is central to operationalizing the ecosystem service paradigm. Clear, agreed-upon frameworks support better decision-making, more effective management, and improved outcomes for both people and nature. As the field evolves, maintaining consistency while allowing for adaptation will be a key challenge. Ecosystem service frameworks bridge the gap between scientific understanding and practical application. By providing common language and structure, they enable collaboration among researchers, policymakers, and stakeholders. This integration is essential for addressing complex environmental challenges and achieving sustainable development goals. Science of ecosystem services is continually evolving, shaped by new research, practical experience, and changing societal needs. As frameworks like CICES are tested and refined, they become more robust and widely accepted. This evolution reflects the dynamic nature of the field and the ongoing quest to better understand and manage the links between people and nature. In summary, defining, measuring, and classifying ecosystem services is a complex but essential task. The Cascade Model and CICES provide valuable frameworks for understanding and managing the benefits nature provides. Ongoing collaboration, research, and adaptation will ensure that these tools remain effective in supporting sustainable development and human well-being. As we look to the future, the continued refinement of ecosystem service frameworks will be vital for addressing global environmental challenges. By building on the foundations laid by models like the cascade and classification systems like CICES, we can develop more effective strategies for conserving natural capital and enhancing human well-being. Thank you for joining us on this journey through the world of ecosystem services. By understanding the definitions, frameworks, and debates that shape this field, we're better equipped to value, protect, and sustain the natural systems that support our lives. The work continues, and your engagement is part of the ongoing evolution of ecosystem service science and practice.